Hello, welcome to Computing with Scientific Notation Part 2. So, this is Chapter 1, Lesson 7, and today we're going to be adding and subtracting numbers in scientific notation. Before we begin, I want to talk a little bit about place value. Alright, and this is a similar process to adding and subtracting fractions, because in fractions we need a like denominator. In this case, we need a like exponent. All right, and that's what this first slide is talking about. When we add and subtract decimals in standard form, we line everything up. So when you were in elementary school and you were adding, 3 or 4 digit numbers, you would line up their place values and add the ones and then add the tens and the hundreds and so on and so forth. In scientific notation, we want to do the same thing, except the place value now is represented by the exponent. So to make a long story short, both numbers must have the same exponent. So number 1, 5.6 times 10 to the second, plus 3.2 times 10 to the fifth. Those exponents have to be the same before you can add. Just like in fractions, your denominator has to be the same before you can add or subtract. So let's take a look at our first problem. So here's example 1. We have 2.85 times 10 to the 7th plus 1.61 times 10 to the 9th. As you can see, these exponents are not the same, so these do not have the same place value. So we got a little cheat sheet here. Do the numbers have the same place value? They do not, so we're going to know. We're going to go to step 1. We're going to change the smaller number. Now, I don't want you to look at just the a value or just the factor. You need to look at the exponent, just like we did on that last quiz about population sizes. The smaller exponent is the smaller number when both numbers are in scientific notation. So this is the smaller number, and we're going to change it so this 7 becomes a 9, and we want to think back it up. So when we back up the decimal point, we're actually adding to the exponent. All right, back it and then up. So here's our number, smaller number, 2.85 times 10 to the 7th. I'm going to back it up. I have to back it up twice, okay? So once to get around the 2, and then one more. So we're going to have to add a 0 and then put our decimal point right here. And that is going to raise my exponent twice. And that's going to look like this. So there's the 1, the 2, and now we're at the 9. Now we're going to regroup. We're going to put the factors together. That's the a values. That's 0.285 and this 1.61. Here they are. We're going to add these together, and then we have our place value, which in addition we just have to write once. 10 times, or I'm sorry, times 10 to the 9th. We're just writing it once. Just kind of like a common denominator, where if you have 1/5 and 3/5, we get 4/5. The denominator stays the same. Well, now our times 10, our place value, our power of 10 stays the same. Okay, we're going to add or subtract these factors, so I'm going to put these together. And that gives me 1.6385. And then we're going to write this number in scientific notation, which is essentially this number times our power of 10. Good, and we have it right there. So let's try another one. All right, we have 6.89 times 10 to the 4th plus 9.24 times 10 to the 5th. The 10 to the 4th power is the smaller number. They don't match, so we have to change the smaller number. So I got to move it back once now to make that 4 a 5. So I'm going to back it up one time, and then that means I raise my power of 10 1 because I backed it up once. And you've seen me do this on the board where I write the little curve and then draw the arrow to remind myself I got to change that exponent. All right, and that's going to look like this. So backing up one time gets me around the 6, and I now have times 10 to the 5th power. We're going to regroup, so we're putting our a values together, 0.689 plus 9.24, and we're keeping our power of 10, 10 to the 5th, just like we do with fractions. We're going to add these numbers together, and that's going to give us 9.929 times 10 to the 5th. So we just did step 4. We put our two numbers together, our power of 10 and our addition. Okay? So literally the same problem here. All right, and then example 3, one more addition problem. Now the smaller number's here. It has the power of 7. I got to back it up once to raise up that exponent to 8. So again, back it up. And it gives me 0.1161 times 10 to the 8th. We're going to regroup. We're going to put this number and this number together. And we have our power of 8 written one time. We add. And then we write these two together. Now, if this is moving too fast, feel free to pause the video. Okay, the steps are the same. This is going to be your key right here. When the numbers are not in the same place value, you have to change the smaller one. And we change the smaller one because when we make this addition or subtraction, we shouldn't have to convert this. This number will be between 1 and 10. All right, if we change the bigger number, then we'd have to move it forward and bring this one down. Actually, we'd have to bring it forward and bring this one down. We'd be at 78.3 plus 1.161, and then we'd have a 79 point something, and then we'd have to move it back again at the end of the problem. So if we always move the smaller number, if we change the smaller number to have the same place value as the larger, back it up, we won't have to do an extra step at the end. We'll be done in this step right here, which is pretty nice. All right, so what we want you guys to do is try these 3 problems. Actually, the answers are right here. I should have had them fly in. That's okay. See if you can do them. So show all your steps, okay, and see if your answers match up, okay? And the homework for tonight are actually these problems right here. So again, you can pause it, write them down. You'll always have them right here. I hope this video helped, and I'll see you guys next time.